That's right. Good morning. All right, very good. Thank you. I know it's early in the morning. I'm from California, and this is freaking cold for me. I'm sure you guys are used to it, but it's getting up this early in the morning is still very cold for me, although I'm a morning person. Anyway, hopefully this will be worthwhile for you. I know you have choices of going in different tracks, and I'm glad you chose this track. Hopefully I'll make it worthwhile for you. We'll keep it entertaining. I have lots of stuff to talk about. I'm more than welcome to kind of take a digression and talk about other things as well. But let's see if we can keep it on the track. I'm here anyway rest of the day at the conference. So if you have any questions, any follow-up that you want to do, please feel free to talk to me. And you can always catch me on Twitter, and I'm generally available over there. Any questions, emails, afterwards, I'm very much accessible. This is one thing we get as part of Oracle's acquisition, putting a legal slide in a technical presentation. But that's where the buck stops. Everything else in the presentation is purely technical. How many of you are using some sort of J2EE, Java EE, whatever that version is, in some shape or form? Excellent. OK, pretty much 95% of you. Very cool. Well, for the others who are not using it, I would highly recommend to take a look at it at least. Java EE 6 is sort of the latest release of the platform that was released on December 10th of 2009. That is the current production release today. It's been one of the most successful releases. The big focus over there was ease of use, productivity, POJO-driven development, and things like that. There have been 50 million plus downloads, and that I'm talking about just the Glassfish component itself, which is the reference implementation of Glassfish or Java EE. 50 million plus downloads just for Glassfish. And we're not even counting, for example, Red Hats and WebSpheres and WebLogics and all those other implementations. So huge momentum around Java EE in general. That's the point I want to convey here. Being the #1 enterprise application development platform, there are 18 plus compliant application servers today that are available for deploying your Java EE 6 application. So you take a standard application built using Java EE APIs, which was anyway one of the big focuses of Java EE. Add capabilities like dependency injection, so you don't have to rely upon third-party proprietary frameworks. Have that capability as part of the platform, then you can easily build an application, a complete application, using the framework itself or the platform itself. And then you can deploy on any of these application servers. You're free to choose. And you can see there is a good variety of open source application servers and commercial application servers. So you have your price point, your touch points are all being served very well. With the latest edition of Tommy, which is really cool. So if you guys are Tomcat users, then you have Tommy, which is Tom EE, which is the enterprise version of Tomcat, with all the Java EE capabilities available in Tomcat as well. So I think it's pretty cool. Now with Java EE 7, our initial focus was to provide a standards-based PaaS platform. But then after talking to community, to partners, to customers, we realized it's a little too early to standardize that. There's still a lot of shaking up going on around that. So the revised scope for Java EE 7, the focus is to really provide higher productivity, kind of keep building upon that, and also embracing HTML5 in different forms and shapes. Now, how do we give you higher productivity? Well, embracing context and dependency injection, or dependency injection a lot more heavily within the platform, so that you have to write less boilerplate code. We're providing richer functionality. So I talked about how we added dependency injection in the platform for Java EE 6. With Java EE 7, we're adding a lot more functionality like batch. You want to build a batch. Again, getting rid of those third-party frameworks that you don't need for building a standard application. More defaults, things like there is a default data source available now. So you want to just take a persistence.xml as part of your Java EE application. You don't have to define a data source over there, because Java EE 7 platform now requires you to provide a default data source as part of your runtime environment. Now, in terms of HTML5 support, as I said, different forms and shapes. So we're providing first-class support for WebSockets. So you can take a POJO, convert that into a WebSocket endpoint, and I'll talk about that. First-class support for JSON processing as well. So you can parse and generate JSON structures very easily as part of your application. Again, getting rid of those third-party dependencies. And then we are also providing HTML5 friendly markup. And we'll talk about each of those points during the presentation. Now, this is what I call as the pancake diagram for Java EE. On the left, what you see is the specifications that have existed in the wild, for a long time. So everything in the gray and orange/yellow, they have existed for a long time. The ones in the gray are getting minor updates. What I mean is, for example, JPA is going from 2.0 to 2.1. That's the specification version number. So that's a minor update. Servlet, 3.0 to 3.1. So that's the minor update. The ones in the orange, which is JAX-RS, is going a major update. That means 1.1 to 2.0. And the difference between minor and major is, in terms of minor, you're probably adding little functionality, some Java doc clarifications, spec clarifications, text clarifications, so on and so forth. In terms of major update is, you're pretty much revamping the entire spec. So for example, in JAX-RS, there are a whole bunch of big ticket features that are coming in, like client API, etc., that I'll talk about. Similarly, JMS. Now, JMS 1.1, if you recognize, the last version was in December of 2003. That was even before JDK 1.4. A lot has changed in the Java platform since then. Generics, annotations, name it. I mean, there are a whole lot of things that are in the platform. And then, in general, how platform is simplified, focused on the POJO-based development. So all of that catch-up is happening in JMS. So that's what I'm talking about, the difference between minor and major updates. Now, on the right-hand side, what you see is a whole set of new functionality coming into the platform. If you take a look at the last 4 boxes, for example, you have concurrency utilities, you have batch applications, WebSocket, and JSON. We'll talk about each one of those. Now, caching API. You realize the number is JSR 107. So that started a long time ago. It's been kind of stagnant for some time. We kind of tried to revive it, got stagnant again. So finally, like last week, we made a decision, actually 2 weeks ago, that JSR 107 will not be able to participate in the Java E7 specification process. So it will not be part of Java E7, but everything else is very much on target to be part of the Java E7 platform, which is scheduled to release in Q2 of 2013. So by release, I really mean specifications will be final. There will be implementation that will be ready for you to use. And then there will be a compliance kit by which other vendors can check for compliance with Java E7 as well. Now, the implementation will be ready at that time, but that doesn't mean it's not available today. So Glassfish, which is a reference implementation work where it's all happening, is already available. The nightly promoted builds, all of that is happening, and we'll talk more about that. So now my plan is I'm going to double click on each of the different specifications and give you a little bit more details about each one of those. Now, I can pretty much give an hour-long session on each of these specifications, but I've been given 45 minutes. I'm sure in about 30 minutes he'll start showing his 5-minute, 10-minute posters to me. So I'm going to just keep it short. But if you have any more questions, you want to see any more code samples on any of these technologies and how these work, and why this, why not this, what is the scenario design pattern, I'm more than happy to talk to you one-on-one. I'm here right after this presentation. I'm going to go to Oracle Community Corner. I will be there so we can talk deep into code. I've got tons of samples that I can share with you. Now let's take a look at what are the new features coming as part of JAX-RS 2.0. How many of you are JAX-RS users? Okay, a few of you. Cool. So now JAX-RS defines a standard API for building REST endpoint. What that means is you take a POJO, on the POJO you put an annotation, and that becomes your REST endpoint. The entire semantics and syntax of REST is available using that POJO. Path parameter, variable template, get, put, post, delete, all those HTTP verbs, all that fanciness was available as part of JAX-RS 1.1. But that was all server-side driven. With JAX-RS 2.0, one of the big ticket features that's coming in is how you can invoke a REST endpoint using a standard client API. I mean, up until now, you really have to use HTTP URL connection to connect to a REST endpoint, do all the data binding yourself, error handling all by yourself. This is a standard client API using the existing concepts. I'll show you a code sample for that one. We're also providing message filters and entity interceptors. Slightly difference between them is one of them is actually wrapping, the other one is non-wrapping. Now, the idea is these are pre and post request and response extension hooks. So for example, let's say your request is going from client to server, and you want to log the request all the way through. Or you want to put in a encryption filter. You know that you control both the client and the server endpoint. Based upon the HTTP headers, you want to do some processing, post-processing, pre-processing. All that can be very easily done using these extension points. We're also allowing asynchronous server and client, which allows your application to be much more scalable very easily. We're also providing support for hypermedia. So think about the case where you are sending a request, you're getting a response back. In the response, you got a JSON or an XML payload, which has, think about a product order, and the product order has a whole bunch of other products. You want to extract one product out of it and get more details about the product. How will you do that? That's where exactly hypermedia fits in. You extract one product, get more details about the product. You get the details about the product. Maybe the product has a warehouse link. You extract the warehouse, then get more details about the warehouse. So that's sort of the concept. That programming model is much more simplified now as part of JAX-RS 2.0. And we are doing some common configuration elements as well. So let's take a look at what my JAX-RS 2.0 client API looks like. So first of all, I need to create a client object. I say client factory.new client. Now that's an expensive object, so the idea is you want to cache it. And why it's an expensive object is because it contains all the configuration for the client, all your filters, interceptors, your binders, so if you want to handle multiple MIME types, so you're going to create that object once. Now once you create the object, once you have the client object, on the client you set a target. The target is a URI that you want to invoke. In this case, for example, if you see here, it says, of course it has host, port, all that detail, but then it says orders, order ID, customer. And order ID is actually in parentheses. So what that means is that's the variable part of my URI. Now, being the variable part of the URI, I should be able to resolve that template. So that's where exactly I start binding the value of the parameter with its actual value. And that's what I'm doing here. For example, I'm saying resolve template, order ID 10. Then I'm specifying a query parameter. So query parameters are like question mark, name equals value in a URI. So I can specify that again using a program. So that's what I'm doing here. Then finally, I'm building a request, and I'm firing the request using HTTP GET, which is my GET call. And I know the response that I'm getting back is string, so I get a string response back. So very simple, very intuitive, very fluent builder API. You don't need to understand all the details, but helping them understand, you can write better and more efficient code. Now, what I'm showing you is a very canonical example. You can get really complex with it in the sense I can start putting my HTTP accept headers in here. I can start dictating, oh, this is the MIME type that I want you to use for on-the-wire message exchange. I don't want get. I want all those put, post, delete, all those different HTTP verbs to kick in as well. So all of that is supported very well. JMS 2.0. Now, the main focus over there, as I said, we released the last API like almost 10 years ago. So the main focus here is to simplify the existing API. If you take a look at the code of how you have to write a simple JMS 1.1 method to send a message is super complex, and I'll show you that in a second. It's extremely verbose because we have to just honor the APIs the way JMS 1.1 was written. So a lot of verbosity in the code, it's a lot of boilerplate code in the code, and there is no resource injection. So the key focus for JMS 2.0 is to leverage all of that to simplify the code that you need to write. So this is the code that you have to write. Now don't try to read the code. It's not meant to be readable because that's how JMS 1.1 is. But the key concept here is this is like about 20 lines of code you have to write, wherein all you want to do here is just send a message using JMS 1.1. Now let's see what are the problems with this code. First of all, at the top, what I'm doing is creating my application server resources. So my queue, my destination, my connection factory, all of that. Then, if you realize this code, this is a try-catch block. In the try, I have a connection. Then from the connection, I create a session. From the session, I create a message producer. From that, I create a text message. Finally, I send a message. So there are a whole bunch of interim or intermediate APIs that I need to kind of follow just because that's the contract. Without that, you cannot send the message. So I have to write a lot of boilerplate code. If I have to do that again and again, then I basically either put them in a method or I keep repeating the code. And then finally, exception handling. Declare connection outside your try block and do that exception handling. If connection not null, then close the connection. All that. It gets really ugly really soon. Now, how does JMS 2.0 handle all of this? The code in the previous slide becomes just very simple now. We are introducing a new object here called as JMS context, which really encapsulates your JMS producer and consumer, because effectively those are your two objects that you want to send and receive the messages from. Now, in this JMS context, you can just inject it, using standard dependency injection syntax. And the way you inject is there's a default connection factory that Java E7 platform has introduced. So using that default connection factory, you're injecting a JMS context. Now, of course, you can override it. You can put, add resource or whatever your connection factory JNDI name is. But the simple code is like this. It's the default, just works out of the box. Now, of course, you have to define what your queue is. So you define your specific queue. Once your queue is defined, then on the context, you create the producer. You send the message to the queue, to the payload. Now, yes, the code is simplified. But I think to me, the biggest improvement here is the semantic readability of your code. For a second, if I go back on the previous slide, if I were to read this code, if I were to share this code with somebody who has to maintain the code, it is going to be a tiresome job. Somebody will have to really read through the code, maybe read through a whole bunch of comments, why this API is created, what this argument means. It's a tough job. If you come here, you exactly know just by reading the code, no comments required. Just by reading the code, it's much more readable, much more maintainable, less lines of code. So that makes it really easy. So Java API for JSON processing. Now that's a brand new API that we're adding as part of the Java E7 platform. The core focus over here is to be able to parse and generate a JSON structure very easily. Now, just like JAX-P, Java API for XML processing, there are two models in JAX-P. There is a stacks model, which is streaming or event-driven model, or there is a DOM API, which allows you to construct DOM objects. Just like that, we have a streaming API here and an object-based API here. Now, in the streaming API, it's a low-level API, where you can say, the object is beginning, the object is ending. JSON is effectively a key-value pair. So the value is beginning or the key is beginning. So you can receive those kind of events and generate your JSON objects or parse your JSON objects accordingly. Or then there's an object model where you say, generate this JSON object for me. You read the JSON object, and you got the entire DOM object with you, and then you play around with that. Now, one of the things that people typically ask in terms of JSON is, what would be really nice is if I have a POJO. On the POJO, I put maybe one annotation. Just like, in JAX-B, for example, you say add XML root element, and it knows everything, using default conventions, how that POJO can be very easily converted to XML. So that's what people are looking for. So they're saying, I can put a POJO on the POJO instead of saying add XML root element, maybe add JSON root element or something like that. And then it should automatically take the conventions and convert everything to JSON. Now, that is not there as part of this API. This is purely for DOM and streaming API. That API is forthcoming. So if I were to show you a sample here, now this is my JSON structure on the top. As I said, JSON is basically name value. So I got first name, :John, last name, :Smith, age, :25, an array of phone number, which is again home, type, :home, number, whatever the number is, and so on and so forth. Now, I can get a JSON parser. From the JSON parser, I can get an iterator. And on the iterator, I can just do, if I were to show you event-driven programming, I can keep getting next elements. So when I say on the iterator, I say next. So that's my first object, or the start of the object. Then I say iterator.next. Then it gives me the key name. Then I say iterator.next. Then it gives me this value. Well, actually, when I say iterator.next, it actually gives me this value. And then from the parser, when I say give me the string, it actually gives me the value. There are well-defined events which you can use to generate and parse the events. So if you're familiar with streaming API, this would look very familiar. It's a very low-level API, so typically used if you want to write something inherent in your application itself. Java API for WebSocket. Now, one of the biggest advantages of WebSocket is it provides two-way communication channel, a full duplex communication channel between a client and a server. And the beauty of this is all of that is possible over a single TCP connection. So unlike HTTP, where anytime you want to make a connection from client to server, always have to be client to server if you want to follow the standard concepts. So from client to server is listening on HTTP. The client initiates a connection. It initiates a HTTP connection, which is resting on a TCP connection. So every connection requires a TCP connection setup, then HTTP connection setup on that. You do some stuff, and then you break the connection. Basically, tear down. Now, HTTP by itself is very chatty. So you have to send about 2 kilobytes of headers just to get the basic hello world going. And if you want to go hello world more than hello world, well, the whole chattiness comes into picture all over again. So that way, it's very chatty. It requires TCP connection negotiation every time. So there are some inherent disadvantages of HTTP. Now, there are some hacks that are available, like reverse AJAX or Comet or pushback and things like that. But those are essentially hacks. There are no specifications for that. There are tons of implementations already doing that. But the problem over there is those are, again, very implementation-specific ways. The programming model, the on-the-wire format, etc. There are issues around that. That's exactly where WebSocket comes in. It says on a standard HTTP connection, now HTTP defines a mechanism to say how can you upgrade a connection from HTTP to a different protocol. The original intention of that was how you can upgrade from HTTP 1.0 to a newer version of HTTP. It's a very standard mechanism defined in the RFC of HTTP itself. Now, WebSocket is actually leveraging that concept and is saying, oh, on HTTP, I can do a connection negotiation, and I will ask for a connection upgrade to happen. And when the connection upgrade happens, then I am actually a WebSocket protocol. So you do the connection negotiation or a connection upgrade on a standard HTTP connection, and when you become a WebSocket connection, then all the messages are over that single TCP connection. There is no tearing down or establishing a new connection for the WebSocket protocol or the WebSocket messages to be exchanged on top of that. Now, it's a single TCP connection, and it's full duplex. That means client can send as many requests, and similarly, server can send as many responses. Now, even though I'm using the term request and response, that's really not the right terminology, because once the client has established a connection with the server, effectively, the notion of client and server is gone. They're both peers. They're both equally capable in terms of what they can communicate with each other. Either one of them can send as many requests, server may not even care to respond, or server can send as many requests and client may not care to respond back. Any protocol or any message exchange pattern, so to say, you have to build on top of that as part of your application. Now, all of that support we are incorporating as part of Java API for WebSocket. Once again, following the standard Java EE design philosophy, take a POJO, put annotation on it, and that actually becomes your WebSocket endpoint. And I'll show you a sample for that one as well. We also have an interface-driven approach. That was one of the feedback that we got from the community, that not just POJO-driven, which is simple, which is good to use, but they want a little bit more control over how WebSockets are written or they do message processing. So we also have an interface-driven approach. And now WebSocket by itself defines a JavaScript API, which is a W3C candidate recommendation at this point of time. In that JavaScript, you define exactly how do you initiate a WebSocket connection, how the connection protocol, all those things happen. And then the second part of WebSocket is the actual protocol, which is on-the-wire message format, which exactly defines how the framing of your WebSocket protocol is going to look like, what a data frame is, what a control frame is, so on. So now for the web part of it, where you want to use it from a web browser, JavaScript is good. That is well taken care of. But from the Java part of it, so let's say you have a Java client application where you want to initiate a WebSocket connection, that's support we're going to add as part of Java API for WebSocket. Now, as I said, in terms of WebSocket, when the message is being exchanged, these are really data frames that are going back and forth between the one peer to another peer. We're also providing an SPI by which you can have access to those data frames, how they look like. So that would allow you to build extensions, for example, multiplexing, multiplex the API, multiplex the data frames, or compress the data frame, things like that. If I were to show you a very simple sample here, so if you take a look at the code, which is in the black only, public class hello bean, public string say hello, and I just concatenate the parameter with hello and return back. Very simple, nothing fancy over there, no interfaces, nothing. How do I make this into a WebSocket endpoint? I just put at WebSocket endpoint, and I specify the URI at which this endpoint is listening. That's about it. That basically converts it into a WebSocket endpoint. Now, a WebSocket endpoint, a message comes in, so you go to dispatch, or you go to designate a method in your Pojo, which will effectively be where you will be listening all the requests. So you say at WebSocket message, I'm going to designate this method. So anytime you send me a request to this WebSocket endpoint, call this business message. Now in this business message, by default, my first parameter is automatically mapped, or so to say injected, with the WebSocket payload. So you have access to that. And then here you're saying hello name. Now in this case, for example, I'm actually building a request response design pattern, because you are sending a request and I'm right away responding back. I could have very well converted this to say public void say hello, in which case I'm not responding anything back. So I can maybe I can build my own design pattern, say every 10 requests I'm gonna accumulate the requests, do some processing, and then respond back. So you can do that. And the way you will do that, for example, is in that case, you can inject a second parameter here, and that second parameter would be my session object, which is again a standard WebSocket object. So, and the session object will encapsulate the client from which the session is being initiated. So you have a capability to say, oh, now session, send the response back after receiving 10 requests, for example. A little bit more elaborate sample here. I have a chat server, for example. This is probably the simplest chat server that you could write. So here I have lifecycle callback methods for WebSocket. What I'm saying is, well, first of all, this WebSocket endpoint is listening at this URI. Then I'm saying anytime the request is initiated with this WebSocket endpoint, call this callback method. This is my lifecycle callback. So open, so call this at WebSocket open callback method. And all I'm doing here is I'm maintaining a set of sessions. I'm just adding which client is now listening to my endpoint. When it closes, I just remove it. And then if I go the same way, I just put my at WebSocket message. And then whenever a message is being received, which is basically my chat message, I just broadcast it to the entire set. As simple as that. And by the way, this is a fully functional chat server for you. Now, you may think about scalability and fanciness and all those things. Of course, you can add upon that. But this will get you going. Bean validation was a new specification that was added in the Java EE 6 platform. That specification allows you to specify your validation constraints or validation constraints on top of a bean. What that means is, think about taking a JPA entity. Now you use that JPA entity to persist data to the database. Let's say in that JPA entity you have a name field, and the name should not be more than 30 characters. If you don't do the validation, the database will do the validation. It'll throw an error back, if it's more than 30 characters, for example. So it'll throw an error back. So it's recommended to do the validation as part of your application. Now in your application, you can do the validation saying, oh, if name.length is more than 30, then return the error back. But that again, you have to kind of sprinkle it at a few places probably. So the recommended method for Java EE 6 is wherein you have the JPA entity. In the JPA entity, you put just an annotation on your field, which says at size, max equals 30. That means I don't want this field to be more than 30 characters long. Once again, think about the semantic readability of your code. You read the code, you exactly know what constraint it needs to honor. So you just put the annotation over there, that is your constraint. So what happens is, every time JPA runtime, or say Eclipse Link, which is the persistence run, or the JPA runtime, tries to persist that entity into the database, it automatically kicks in, the validator automatically kicks in, tries to validate the data, and if it doesn't meet the requirements, it throws an error back. So instead of you doing validation as part of your application, the JPA layer is taking care of it for you as part of the entire Java EE 6 stack. Now, that all exists in Java EE 6. As part of Java EE 7, we are allowing that capability on your regular POJO objects. So for example, in my EJB, I have a simple place order method here. I have 3 parameters here. I could say, I don't want the product name to be null. I don't want the quantity to be null. Not only that, but I don't want the quantity to be more than 10. And then those are my built-in constraints. I can actually create a custom constraint as well. So for example, for my third parameter, which is string customer, I could have a POJO saying add customer. And in that POJO, I can define exactly how my constraints are going to look like. So that will again, if you read the code, you know exactly. Instead of going through if-else loops and returning and error conditions and things like that, there is a central place, a central design pattern on how you can define these constraints. You look at the code, you know exactly what it means, and you just move on. Now the last bit of code fragment here is, for example, you're saying, get me an appointment date, and you're saying, I want this date to be in the future. So that means if you try to return a date which was in the past, it would just return an error back. It won't even return to the thing, to the caller object. A new functionality that we are adding as part of Java EE 7 is how you can easily do batch applications. Now, of course, a lot of this is influenced by Spring Batch. So if you guys are using Spring Batch, this would sound very familiar. The core concepts really here are, how you can do non-interactive, bulk-oriented, long-running tasks very easily. Now, these tasks are generally computationally intensive, could be disk intensive as well. But the idea is you don't want to do them during your prime time. It's okay to kind of do them during off hours. For example, sending bank statements. It could be done like midnight when you're hopefully nobody's accessing or the system is not that heavily loaded at that point of time. So the key concepts as part of batch applications are how there is a job repository, which is, for example, at the bottom here. Now, this job repository contains all the jobs that you have scheduled. That job repository, from that repository, a job operator, which is right here, the job operator picks up a job. This is my one job. A job could have multiple steps, and a typical step could have 3 sort of sub-steps in there, or we call it chunk. A typical design pattern is where you are reading a record, processing it. Reading a record, processing it. And you're doing that n number of times. And once you have done that n number of times, then you are just saying, okay, write the record. For example, if we were talking about the sending a bank statement. So you read a record, you calculate the bank statement. You read a record, you calculate the bank balance. Read the record, bank balance. You've done that, say, 10 number of times. And then you say, okay, now send bulk email to all of those accounts. And then you repeat that all over again. All of that is fully customizable. Now, the way you specify that logic is using called as job XML. In the job XML, you really define, for example, I have a step called as send statements. The send statements is basically a chunk. In the chunk, I could have a reader, which is my account reader, a processor, which is account processor. These are all POJO clauses, by the way, and an email writer. And I define what my chunk size is. So remember, I was saying read, process, read, process. That cycle is defined as a chunk size. Now, in that POJO, like account reader, which is my POJO class, I have a method which is tagged with add read item annotation. So what I'm doing potentially is reading an account using JPA here. Account is my domain object. Then I'm processing an account. So I'm taking an account and I'm returning an account back after calculating the balance, or the method signatures could vary as well. And then finally, I have the list of account to me. So I'm processing that entire list and sending an email to all the accounts. So that's sort of how we're going to tie up all the things together. Now in JPA, as I said, it's a minor release, but we're still adding some cool features. For example, you can take your JPA entity. From that JPA entity, you can easily generate schema. Now, JPA, if you realize, is a pluggable persistence provider mechanism. So that means you use a standard API and you define what your persistence provider is going to be. Most of the time, that persistence provider is already part of your Java EE implementation and is default. So for example, if you're using Glassfish, then Eclipse Link is the persistence provider. Although you can configure it. So for example, if you're using Glassfish, then you can still specify, oh, JPA, use Hibernate as my persistence provider. That's okay. So one of the things that we're doing over there is taking a JPA entity, generating a corresponding schema to it. Now, most of the persistence provider already provides some mechanism for that, but what we're adding is standard JavaX persistence APIs, or properties rather, with which you can generate the schema. So the idea is you implement your domain using JPA entity, then you can specify those properties. It will generate your schema, not only schema, but it could generate your SQL scripts. So you can take a look at your SQL scripts. Then you can evolve your JPA entity and your database SQL scripts independently. So for example, you can give those SQL scripts to your DBA, who would then tune them up for you. And then here, you have your JPA entity, which could evolve independently as well. Of course, making sure that they are able to talk to each other. And there you go. Now, in production, you would not just say, okay, now generate my database on the fly. That doesn't happen. So the idea is, but that model is supported now in the sense, from JPA, you can generate DDL, or domain data definition language, which can be independently tuned, and then you can generate your JPA entity back from that. So it allows you rapid prototyping, making sure your JPA entity and your generated DDL are kind of staying in sync. We're also allowing unsynchronized persistence context. So that allows you the capability to make sure that you can make changes to persistence context, which by default are persisted to the data store. Now here you have to explicitly join a transaction in order for the changes in the persistence context to be refreshed in the data store. We added a criteria API in JPA, which was a type-safe API, which would allow you to easily query a database using type-safe language. JPQL, or Java Persistence Query Language, which exists in Java EE 6, or which existed in the earlier versions of Java EE, is not type-safe because it's all string-based. But criteria is type-safe. But in Java EE 6, the problem was, or the limitation was, it was only for querying. Now you can do actually update and delete as well. We're also adding support for stored procedure queries as well. In Servlet 3.1, a couple of minor additions. The first one being non-blocking I/O. And I'll show a sample of that. And then, as I talked about, how you can do standard HTTP protocol upgrade, which is actually used by a WebSocket implementation for us. Now, in a traditional way, so today, for example, if you were to do I/O in your servlet, which is your servlet do get method, you would do something like this. So this is my servlet do get method. I got my servlet input stream. I'm reading data from the client who's sending the data to me. I keep reading in a loop, and then I'm stuck. So what if the client has not closed the stream? This is not scalable. This is not a good code because my thread is blocked all along while I'm reading the stream. So with that, in Servlet 3.1, we have non-blocking I/O. What that means is, in an asynchronous servlet, you can easily say, we have defined read listeners and write listeners. So not just input, but you can do output in an asynchronous manner as well. So you would define your read listener, which would actually have callbacks, which are invoked when the data is available. Similarly, write listener have callbacks, which are invoked when the data can be written to the servlet output stream. So here, I get my request input stream. On the input stream, I set my read listener. Read listener has this method called as onDataAvailable. In that onDataAvailable, all I'm checking is, hey, input is ready. If input is ready, then keep writing to it. And if input is not ready, the thread is actually parked, and you're back in your servlet if you want to do something else, or the thread is available for other consumption. So this allows your code to be scalable. This allows your thread not to be blocked, and it's a much more efficient utilization of your resources. Once again, a new functionality coming in Java EE 7 is concurrency utilities for Java EE. Now, Java EE is a managed environment. What that means is, everything is literally managed by the container. So you cannot spawn your new threads, or at least it's not recommended to spawn your new threads. So with this concurrency utilities, now you can ask the container for a managed thread. And the way it would work is, you will, well, let's show a code for that. In your web XML, for example, you can define your resource environment reference. So this is your JNDI name, for example. And then you're saying what the reference type is going to be. It's JavaX Enterprise Concurrent Managed Executor Service. So you're saying in that, using that resource environment reference, create a JNDI name in this time frame for me. Now in your actual application code, what you can do is, so this is my servlet, for example. I'm saying at resource name equals concurrent batch executor, which is the same JNDI name that I showed earlier. And then I can say executor.submit a new task. My new task is probably running in a new thread. So this is a managed thread that is now available to you as part of your application. You can certainly tune this thread pool. You can define certain parameters on how big the thread pool needs to be. What is the timeout for the thread pool if it's not being used, or a particular thread, and things like that can be very easily configured as well. But that is one area where the spec is still looking for feedback on exactly what parameters are really relevant for you. Now in Java Server Faces 2.2, which is again going through a minor update, one of the big features over there is how we are adding support for Faces Flow. Now, Faces Flow, again, is a feature that we have picked up from several other technologies. So, for example, ADF Task Flow, or Spring Webflow, or Apache MyFaces Cody, they all have this capability by which they can allow you to package your flow-related items. Items could be your pages, your beans, in a module. So, JSF is introducing that feature now. So, for example, what is the flow? Well, I'm doing a checkout cart. In the checkout cart, I have a cart page, I have a credit card page, I have an address page, and I have a confirmation page. Now, typically in a JSF application, all of those pages are either in a directory or scattered around, but if I want to reuse that functionality, there is no way for me to package them up together and reuse elsewhere, or at least there is no standard way of doing that. So with JSF 2.2, they're saying, oh, we can define an actual flow out of those pages, and we are defining a packaging mechanism by which those pages, either view or the backing beans or together, can be packaged and can be reused as a module in different applications. We are also doing HTML5 friendly markup, and there are some other features coming in as well. Now, most of the features that I talked about are already integrated in Glassfish 4.0 today. Now, as part of Java EE 7, Glassfish will be released. So you will have an access to Java EE 7 SDK. But the promoted builds are very much accessible today. And I mean, I've been using it. A lot of folks within the Glassfish community are using it as well. Now, going forward, the focus, as I said, in Java EE 7, the focus was on providing a standards-based PaaS programming model. But going forward, Java EE 7 is going to form the basis for everything that we're doing around cloud. So for example, we will provide support for, as I said, JSON binding, PaaS enablement, a standard architecture for thin server architecture, multi-tenancy, NoSQL, storage. All those APIs are going to come as part of Java EE 8. Now, one of the excellent community efforts that was started by the London Java community was Adopt-a-JSR effort. How many of you are familiar with that effort? Oh, a few of you. Cool. So Adopt-a-JSR is a beautiful effort started by London Java community. It's basically about grassroots evangelism of the activity that is happening in JCP. With Java EE 7 sort of having the main chunk of activity happening right now, I think it's a wonderful time for you to get involved. Now, what is it? It's basically think about, if you are working as, well, let's see. How many of you participate in a JUG actively? Some of you. Oh, wow. Okay, wow. More of you guys should really do it. I think JUG is where most of the innovation is happening, really. So the idea is, if you are part of a JUG, well, first of all, if you're not part of a JUG, you should join a JUG. Then second, if you become part of a JUG, then the idea is your JUG, or as an individual, for example, you can download the specification, you can download the implementation, take a look at the specification, try out the implementation, see what is your use case. So you want to build a WebSocket-driven application. What would that mean to you? How would you play around with it? If you want to try out schema generation, if you want to try out JAX-RS client API. So pick a JSR, or pick a combination of JSR, and then say, I'm going to try it out, and I'm going to provide feedback to the expert group or the JSR process, saying, okay, let's make it successful, because this is my use case. I want to make sure that your JSR is serving my use case. That's what this effort is all about. And there are different levels of involvement. It could be as simple as just downloading the specification, reading a chapter, saying, oh, there's a typo here, that's good. You can, of course, up the ante. You can go from, oh, I'm going to read the specification, and I'm going to try out the implementation, I'm going to read the Java docs, and see, is the spec consistent with the Java doc? Or, for example, these are 19 different JUGs around the world, and literally around the world, Asia, Africa, Europe, South America, North America, who are participating in this Adopt-a-JSR program for Java EE 7. One of my favorite examples is from the Chennai JUG. These guys, one of the early adopters for the Adopt-a-JSR program, they have taken 5 or 6 different JSRs. They're building an end-to-end application, which is actually beautiful, because this allows you to see, most of the time, the spec leads or the implementation team, they put their blinders on, and they work in their own silo for the application or the implementation. That's where people like you and me help them out. Even though I'm part of the Glassfish team, but I give them the value, how all these specs should really work with each other. Chennai JUG is doing exactly that. They're saying, we're going to take this 5 different JSRs, build an end-to-end application, JSF, WebSocket, JSON, JAX-RS, JPA, all of that, see how they really work with each other. Is the programming model simple? Is it intuitive? Do they blend with each other, or are there inconsistencies? What does it mean by using, if I want to do a batch programming, can I use it with EJB? Can I use it with Servlet? Or do I use concurrency for Java EE? Different features that they're trying out and providing feedback. So if you are not part of a JUG, highly recommend to join a JUG, and then go poke your JUG leader. You join that JUG very first day and go poke him. I want to participate in this. I want to make it successful. So I will conclude with the references that I have available. So javaespec.java.net is where you can find all the specifications. Glassfish.org is where the implementation is happening. This is a blog that we actively update. Adopt-a-JSR efforts are defined here. And then, of course, NetBeans has a development version where we are doing a very cool stuff on Java EE 7 development. So if you give me a chance, like about 2 minutes. So here, what I'm running is NetBeans IDE. As you can see, this is a nightly build, literally from February 5th, so from yesterday. So this is a pretty cutting-edge build. But here, I have Glassfish Server 4, build 72 configured here. I can manage everything from here itself. I can look at the applications, resources, etc. Then I can go to Files. And I can say, create a new project. Oh, not Files, actually. Projects, sorry. In Projects. So I can go to Projects, and I can say, create a new project. I can create a Maven web application. When I go here, I can give it a name. Let's keep the simple name, for example. And here, I can actually choose Java EE 7 web application. So I'm creating a simple Java EE 7 web application here. I click on Finish. It's using a standard Maven archetype to generate my Java EE 7 application. If I look at my project files here, I have my pom.xml. In the pom.xml, I'm using a standard Java EE web API. In here, I can right-click, I can say New, as you can see, I can create a WebSocket endpoint. I can create a JAX-RS2 filter. I can create a RESTful Java client. So I have all sorts of features that are available that you can actually explore as part of NetBeans IDE. So once again, if you want to go back to Adopt-a-JSR, spec, RI, implementation, tooling, all of this is on a pretty cutting edge right now, but I think it's going to look really cool. And I'm really enjoying it and having a lot of fun with it. And I have about a minute to ask any questions. Otherwise, I'm going to go to the Oracle Community Corner, and we can continue our discussion there too. Questions? Oh, it was overwhelming, I think, for that morning. Anyway, thank you very much.